Thank you. It is, I will say, quite honestly, great to be here. It's funny, looking around the room, I had figured, all right, so we'll get here and it'll be a room full of people and I'll know a handful of them. Actually, I'm surprised. I want to say I probably know a third of the people in this room, which is, to me, astonishing because I think only 10% of the folks here are actually from Google. And that means the other 20-odd% that I know are either people who used to be at Google or people I've run into in my travels. And I will say, as a representative of Google, of course, I think it's the greatest place on earth to work, and I love working there. But as someone who's fundamentally a computer scientist, it's great to see that this discipline has expanded well beyond Google. Because as I look forward over the next 10 years, right, we have cloud computing. We do sort of see the end of on-premises compute for most uses of compute in the world. This is actually what the future of computing looks like on Earth. And what you all are doing right now is going to become common practice and eventually normative for most of the compute cycles on the planet. And that, frankly, is pretty cool. So it's good to see everyone. And it would be even better if the slides worked. All right. So first of all, a little bit about me. I'm a computer software engineer. It's been very clear. I actually wrote my first program when I was 6. The first time I saw a computer, that was sort of the last time I watched TV for about 4 years, because this was clearly the thing. And started programming, loved it, read books, taught myself assembly language when I was 9. Actually started at Oracle as a software engineer when I was 17. Funny story there. I was, freshman at Stanford. Picked up the Stanford Daily one day thinking, it'd be kind of nice to get a job. You need to have some money for laundry detergent. And they said, hiring software engineers. And it didn't occur to me at that time that what they meant was graduates, right? And so I called them up and said, hey, I know C, right? You're advertising for C. And they said, well, we're looking for graduates, but why don't you come up and interview anyway? And of course, they interviewed me with C. I knew C just fine, and that was that. And so I started working at Oracle. I think I was the youngest guy there for 5 years. But my entire life has been software engineering. And so when I joined Google, it was to run this little team called production, which was 7 people at the time, who were all software engineers. And from my perspective, basically site reliability is what happens when you ask a software engineer to design a group that does what used to be operations. And this is much the result because I've designed the group in a way that I would like to work in as a software engineer. And yes, the team has expanded slightly over the years. So one of the key questions then for me as I got here was, well, what should I talk about? I mean, there are so many fun things after more than a decade at Google. We have, war stories that I could spend an entire hour just going through, and they're all at least funny to me, and most of them will be funny to all of you because you've seen these sorts of things. But, snakes in your transformer, and horse funerals, and why sea bass is actually a really ugly thing called Patagonian toothfish, and why you have to trench fiber at 8,000 feet down, and so on and so forth. At scale, as you all know, things happen that you would not have dreamed, right? Things that are, on an absolute scale, extremely unlikely in any given place in any given time become quite likely when your massive scale, gamma rays affect RAM, right? Who would think that's a problem? Actually, it's a common enough problem you have to have systems that deal with it. So there's lots and lots of cool war stories because we deal with such big scale. Or we could talk about tools and systems. Well, gratifyingly, actually, most of the rest of today is going to be talking about tools and systems and practices. So I chose not to do that, but I also chose not to do that because, honestly, you all are better at doing that than I am at this point. I've spent too much of my last decade designing and managing a team as opposed to writing code. And best practices, similarly, a lot of them are common. I think some of them are probably unique to each company here. Would have been a good topic. But actually, when I thought about it, I said, well, I'm most uniquely qualified to talk about what makes SRE. And I use the term SRE, but to be clear here, I'm talking about Google SRE. For each of you, to your companies, we'll practice it slightly differently. What makes SRE actually SRE? What are the things that distinguish it from other teams that either do operations or that do software engineering? And one of my observations as I thought about this is, I've talked for more than a decade about the importance of documenting everything, right? You've got to write it down. You've got to have it there. That's the only way you can get improvement, blah, 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 blah. And I've never actually written down anywhere, well, these are the principles of what makes SRE SRE. I'm like, ay, ay, ay. There's clearly a meme here, right? No question. So let's just get it out of the way, and then we can move on. So what actually makes SRE SRE? It's simple. It's just these things, right? Hire-only coders have an SLA, measure and report performance against the SLA, use error budgets, gate launches on them, have a common staffing pool, have excess work overflow, cap the operational load at 50%, share for 5% of the work with ops with the dev team, have an on-call that's at least 8 people, maximum 2 events per on-call shift, post-mortem for every event, post-mortems are blameless, and focus on process, not a lot of people, right? Straightforward. So I will spend the rest of the presentation actually talking about these in some depth and really talking about the why of them, because the why is important, right? Every company is going to be unique. Every situation that you find yourself in will be a bit different, but the principles, the underlying philosophy, I think you'll find repeats over and over again. And certainly from my perspective, managing what is now a team of about 1,300 SREs, I see the same movie over and over and over again, right? And the characters are different, the plot twists are slightly different, but the basic theme of the movie is exactly the same. And so it becomes easy to see these recurring themes, and that's what I've tried to abstract out here for all of you. And my hope really is that you'll take away some of these themes and go back to your own work and say, oh, you know what? We could actually do this thing differently, and we'd get a better result. So that's my goal for this roughly 40-minute presentation. So question number one is, you know, why are we even here, right? Why do we have an SRE team? Well, so my favorite saying, and it has guided my own philosophy in working with software products, is, you know, the number one feature of the product, the most important thing is that the product works. Second most important thing is that the product works. And the third most important thing, you know, say it with me, the product works. So, you know, why am I so sure? Well, it's easy to demonstrate. Let me give you 2 different products, right? And obviously everyone, it's probably not obvious, most of you statistically here are familiar with Google's Gmail product, right? Not all of you have used it. Probably all of you have at least seen it. So Gmail's a pretty full-featured, you know, very nice, easy to use, transparent, intuitive, blah, 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 pitch off Gmail service. But suppose you stripped out some of its key features. Like suppose we rewound 4 years to what Gmail looked like in 2010, right? Missing a bunch of stuff, doesn't do organization nearly so well, doesn't do binning, there's a bunch of task bits missing, the search wasn't so great. Do you prefer Gmail 2010 or this other product I have, which is called Gmail 500? Okay. Okay, so any other questions, right? What's more important, the latest feature or that the product works? I'm going to assert the product works, right? So that's great. We all agree this is the single most important thing that any product can have, is that it actually works. Why is that a challenge? Well, it's a challenge because it's so easy to take for granted, right? It's like air or certain other things. They're no big deal until you can't get any. And also reliability in particular is characterized by an absence of errors, right? It's not like you fire it up and you see the reliability-o-meter, right? It's literally you fire it up and it works, and after a while, it becomes easy to assume that because it has always worked, it will always work. And I think it's not news to anyone in this room, that's not actually the case, you know, at all. And furthermore, because these are typically all complicated, involved systems, by the time the thing stops working, it's not like one thing has gone wrong. A whole set of things have gone wrong. It's what's called a systems failure. And so by the time your service actually becomes unstable, typically there are 3 or 4 or 5 different places where things have come badly off the rails, and you have to fix all of them to get the service back to real health and reliability. And because, you know, all of us have defense in depth and graceful degradation and fail tolerance and sharding and so on and so forth, you can get a fair amount of pathology in your service without really noticing it. So once it starts breaking, right, you've got a lot of cleanup to do. So there's this big basic challenge, which is, you know, the thing that's most important about your product, nobody's going to pay any attention to it until it's very late in the game. And you can see this as well because all of you, I'm sure, have your own favorite example of a service that you know that you like that doesn't work very well, isn't very reliable. It can be a web service, it can be a car. And once you get to the mode where the things aren't working very well, it's not like the management suddenly wakes up one day and goes, oh, well, this isn't working very well. We better, turn the reliability meter back up to, to 10 and down from 6, not from 6. It takes them months, frequently more than a year, to make a system reliable again. So you really can't, as a business, afford to get into the state where things aren't reliable. So for that reason, SRE has to be its own team. This is my basic thesis, right? If you don't have a team who views their mission in life as making sure that the product works, you will ignore availability and reliability until you're in real trouble, and then it will take you a long time to dig out. And I think all of you probably have seen multiple examples in your career of where a team wasn't focused on reliability and it finally became important, and then it took them a long time. And they weren't focused on reliability for name any one of 100 reasons, but they weren't. So having a team who's always focused on reliability, who views this is the most important thing in the universe, is the best solution for ensuring that your product is reliable and stays reliable. Okay, so I skipped to the next slide here slightly prematurely. So we agree, presumably, that it's important to have an SRE team. But SRE is ops, right? And dev and ops always fight. Like, this is the classic thing. And if you read the literature, well, for computers, at least back through the 60s, but if you take the equivalent, right, group functions, the people who develop things and the people who make things work, you could go back thousands of years, and you would always find that there's basically conflict between these two groups. So is it inevitable, right? Will we always be at war? Is there always going to be conflict between a group that does reliability and availability and a group that does feature development? Well, so let's look at what drives this first before I answer the question. So, we use lots of words. We talk in great detail about what the teams do, what their motivations are, and so on and so forth. But when you strip away everything else and you look at the core of what drives teams, right? The things that drive a development team, I assert, and you can argue with me, is they want to launch cool new features, change the world, and get big adoption. Simple as that. Developers want to launch new features and change the system. At its core, an operations team doesn't want to have the damn thing blow up on their watch. Right? Now, preferably not blow up on anybody's watch, but particularly not when you're the one in charge. So these two goals are in conflict, right? Because, I'll change my notes, not that I've been reading the notes, but it's nice to know where I am in case I lose my place. At its core, development teams are trying to change things, and the number one cause of errors and outages, in my experience, has been when you change something. Right? I like to joke at Google that if I wanted to get great reliability at Google, it would be simple, right? Freeze the source control system, freeze the release process, lock down all permissions for images and so on, and take a 6-month vacation, right? Because pretty much other than user growth and a little bit of capacity planning, we wouldn't have to do anything. Google would run great for that period of time. This is what we call local optimization, right? Great for me and my peace of mind, not so hot for Google overall. But it points out this fundamental conflict, right? The operations team, if you view your goal as being to make sure that the thing doesn't break, then at its core, you want there to be no change, because minimizing change minimizes risk, minimizes outages, et cetera. But that's not good for the company. Now, of course, everyone understands that, right, in practice, you don't want to do this. So what you find is nobody actually says, right, I want to freeze all change and lock down source control and take a vacation, right? We say different things to mitigate this risk. Well, we need launch reviews, right? Because we've had this launch had a disaster, and that launch had a disaster, and this thing missed these 3 things. So we need to have launch reviews, and those launch reviews need to be gating, right? You can't launch anything unless it's had a launch review. It seems totally plausible. Every company that I've seen that launches software at scale ends up with a launch review. Well, it turns out that's not enough, because there's a bunch of things we miss during launch reviews. So let's have a product deep dive, right? And there'll be, phase gates. And we'll have a bunch of the people from the operations-oriented team show up at that, and they'll think of all the different ways that the product might break, right? Could break, hypothetically. There's some rare case, but it's rare, but it's catastrophic, so we really got to worry about it, right? So you have product deep dives. We develop checklists. Okay, well, here's all of the things that have ever caused an outage ever at our company or at any other company we've ever heard of, right? We better make sure we don't do any of those things. You release checklists, and these things eventually end up being big enough you need a spreadsheet to track them, and then you need a TPM to manage the release checklist. I mean, right, this goes on and on and on. And even after you launch, well, you can't really launch the thing all at once because that's really risky. Like, what if there was something we missed? So we better do a 1% experiment, and we'll call it a canary. And then, you do the 1% experiment, and that should run for like a month, right? And then after that, it's probably safe. But to be sure, since you get different traffic mixes and different geographies, we should do a canary in each of the different clusters that we've got around the world, just to make sure. And, you run that for another 3 weeks. And, okay, now we've got enough flight miles, right? So this is how it comes out in practice, right? Nobody says zero change. Everybody says blah, 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 risk mitigation to the nth degree, blah, 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 for all releases. Okay, so the development team, of course, being no dummies and having their own separate set of incentives, has counter tactics, right? Well, this isn't a release, right? This is a flag flip, right? Oh, come on, everybody's heard this one, right? This isn't a release. This is a feature ad, right, on an existing product. We're not launching it. It's just it's a low-risk UI change, right? It's a 20% experiment, right? Like, the list goes on and on. Once you've defined a bunch of process to mitigate risk on launches, the development team will come up with a whole set of new launch procedures that change how code gets deployed into the wild without running into all of the process that you've built to try to mitigate risk. And this is absolutely classic, right? But it's even worse. Because the other big problem that you have is fundamentally, the development team actually knows the code much better than the operations team does, right? They spend months and months and months, well, not 24 hours, but let's say 10 hours a day, 5 days a week, working on this, talking with their colleagues, doing design, blah, blah, blah. They know this code inside and out. So they know the code much, much better than the team that's trying to figure out whether it's going to blow up when it actually goes live knows it. And so you have this situation where the team that actually knows the least about the code has the strongest incentive to object to it launching, right? So, this is structural. This is just how the teams work. It should surprise no one, given these facts, that you end up with conflict and tension, right? You've basically engineered it, right? And so one of the things that I found very fun about being a manager is, since I'm fundamentally a software engineer who got tired of seeing management done badly and got into it myself, I see these situations and I'm going, no, actually, I think we can do better than this. So I will propose, actually, that this conflict is not inevitable. And the way around it is to change how the incentives work. And that's what we've done in Google SRE, and that's, I hope, what all of you will take away and do. So the key, essentially, is this. The SRE team at Google, again, doesn't attempt to assess launch risk. We don't attempt to avoid outages, and we don't attempt to set release policy. We do none of these things. Okay, well, you say, okay, that sounds great. How come Google's still running? Because what you've just described sounds like, there's probably another 30 minutes before the first big outage. So what do you do instead? Actually, it's something we call error budgets. And I will talk about that because it's not an entirely trivial topic, but it's incredibly important. So an error budget is actually how we do releases at Google and how we avoid this structural tension with SRE and development. So to have an error budget, first of all, you need an SLA. Let's talk about what an SLA means, because the term means different things in different companies. And I've seen SLAs and SLOs and SLIs. And I'm just going to use the term SLA here. So what is an SLA? An SLA is fundamentally how reliable is this system going to be to its end users, right? So there are very, very, very few things in this world that need a 100% SLA, right? That is, they work all the time. I'm going to submit to you that pacemakers are one of those things where I would really like the manufacturer to have a 100% SLA. Should I ever need one, I would prefer the 100% SLA to the 99.95% SLA. Thank you very much, right? Anti-lock braking systems another one of those places where you really are kind of looking for the 100% SLA. And in fact, they go through and do provably correct code for these, which ends up meaning that the code is tiny, right? But it gets in the way of innovation, blah, blah, blah. But it is one of those systems where you'd really like it to work all the time. So what are things that don't need a 100% SLA? Well, anything that has a computer involved with it. You may be familiar with these devices. I hear they're popular. There are also mobile versions of them. Those are even more popular, and they're even less reliable. I want to say, personally, this thing is somewhere between 1.9 and 2.9s reliable without even considering the software on it, right? You know, if you say, do you pull out your phone and 99 times out of 100 it does what it's supposed to do? No, right? Okay, fine. So it's not 2.9s. 2.9s or 3.9s if you're talking about a laptop, maybe. Depends on whose operating system you're running. That is a pretty reliable system, to be sure, but it is nowhere near 100% available. Okay, so if the fundamental devices that our users are using to access our services are nowhere near 100% reliable, our users will not notice if our service is not 100% reliable either. And this is a very, very important point, right? So if the users, at the end of the day, you care only about the user's experience using your product, if the devices that they are using to access your product are nowhere near 100% reliable, then your service does not need to be close to 100% reliable. For them to have the experience of essentially all the time that the service doesn't work, it's not your fault, right? So, suppose you're using a 99.9% laptop because it's, well, Linux, obviously, given this crowd. If your service is, 4.9s reliable, that means only 1 error in 10 that they would see would ever be from your service. That's actually pretty good. It means 9 times out of 10 it's something else. So, 3.9s access device, 4.9s service, sounds good, right? Well, so let's talk about that. If it's a 3.9s service, for example, right, roughly speaking, it's a mobile service, and so the device is 2.9s, the service is 3.9s, then your SLA is less than 100%, it's 99.9%. That means that you have a budget for errors that you serve of 1 minus your SLA. So 99.9% SLA is 0.1% error budget. And so if you have a small service, like 1 billion queries a month or something like that, that means that you can serve 1 million errors a month and nobody's going to care. And that is really important, right? So back to this point. So if you have an error budget, your error budget is 1 million errors a month, which is quite a bit. And we know that changing things is the #1 cause of outages and the #1 cause of errors. Well, then the question is, what do you want to spend your error budget on, right? Well, you got 1 million errors. You can have a service that's basically flaky, and every time a server dies anywhere, it spews out 2,000 errors and blah, blah, blah. And so you spend 80% of your error budget just dealing with day-to-day operations stuff. Or you can have a service that's actually quite reliable. It deals very gracefully and very quickly with routine and normal failures and actually on its own generates very few errors. That means you've spent very little of your error budget on the service, and you have a lot of your error budget left for launches. So this is actually exactly how we do it. And the key essentially, right, is that your launch policy is as simple as this, right? If the service is within SLA, launch away, right? And the pattern roughly goes like this, right? Look, SRE is, we have an SLA, we've agreed it's a product characteristic based on how the user is using it, what they expect, what the competition is, blah, blah, blah. SRE's job is to measure compliance with the SLA and to enforce a very simple launch, no launch rule based on SLI compliance. As long as you're within compliance with the SLA, clearly as a development team, you're doing a good job, right? You've accurately assessed how reliable your service is. You're doing a good job with your own internal care for launch prep and review and design and so on and so forth. Knock yourself out. We trust you. And that works beautifully up until, the first truly spectacular outage, or for that matter, a service that becomes increasingly flaky and eventually is spewing too many errors on its own. And now we're not inside SLA anymore. And at that point, unfortunately, right, remember information asymmetry, SRE can't really tell whose launch is safe and whose launch isn't safe. We don't know. You know the code better than we do. So nothing launches until you've earned your way back into SLA compliance. It's a simple rule. It sounds too simple. I was a little skeptical of it when we first sort of thought it up and thought, this might be the way to go. We actually talked about printing up big stacks of $500, right? Because you start each month with a bunch of 500s, and then as you spend them, right, you actually would move them over. It's just a visual, but it's sort of helpful. But it seems like a very simple rule, and yet what it does is it gives you a self-regulating system, right? As long as the service is meeting its SLA, we have very few restrictions on what the development team is allowed to do. They love that. We love that because we're not fighting with them. We're just looking at the same piece of data. And because change is the #1 cause of outages, it regulates yourself so that you end up running just about exactly at SLA. Now, if it turns out, that you discover that running at SLA makes your users complain or makes your executive's hair catch on fire, you can always change the SLA. It's a product question, right? Not a technical question. But what you find is if you turn the SLA up, releases slow down. Right? So it's this innovation versus stability dial that you've got. But the SRE team isn't setting any release policy. There's no conflict with the development team. In fact, you're on the same side in this because what you really both want is launching lots of cool features and winning in the marketplace and driving your competition to heavy drink and suicidal thoughts and eventually changing companies. You all want that, but you have different jobs in this. By giving both groups the same incentive, which is minimize the amount of errors so we can launch stuff as fast as possible, puts both groups on the same side. And in practice, it works beautifully, much better than I would have thought. And it actually works well for 2 reasons. The first, as I've just said, is that it removes this whole source of conflict, right? It's not the SRE team trying to figure out whether the dev team has done a screwy launch or not. You're both looking at how the thing actually performs. You're looking at an SLA that you've all agreed is the right way for the product to show itself to the user, and then you're just measuring what happens in simple on-off gate. That one I anticipated. I thought it was going to be cool. The bit I didn't anticipate, but in retrospect is obvious, is actually development teams aren't one monolithic team, right, with one single thing that they're working on. Development teams are actually many, many different smaller groups, each of whom have their own features that they're each working on, et cetera, et cetera. And pretty quickly that they figure out that the name of this game is self-policing, right? Because I don't want your screwed up, poorly tested, under-designed, under-spec'd feature to launch and blow the error budget before my really cool, world-beating, all-conquering feature goes out 2 weeks later, right? So they self-police like you wouldn't believe, precisely to make sure that they don't blow the error budget on things that aren't important. It's wonderful. Brings a tear to my eye. So, error budgets, right, and what we call launch on black, which basically means as long as you're not in the red on your budget, go ahead, works like a charm. And this fundamentally removes the biggest source of conflict between the SRE team and the dev team. So let me switch to topic number 2, which is what about staffing? What about the work that people do? What about what we call ops overload, which is, yeah, okay, that all sounds great, right? This removes conflict, but you can still end up with your team owning all of the crap work and being so busy with the crap work that that's all they do. So fundamentally, right, the tension, right, the structural thing that drives this is at the core, stripping everything else away, you can make a badly designed and badly assembled system continue to run by throwing lots of people at it. Right? The thing constantly needs maintenance, it needs upgrade, everything is manual, there's no written procedures, there's no automation, yada, yada, yada. Fine, right? Take another 30 people, assign them to the ops team, and we'll get through this. I've heard that one a few times in my career. Can't we just power through this for the next 6 months? This release is really important, blah, 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 blah. It's always different words, same movie, right? So fundamentally, I'm a software engineer, right? The job that I just described sucks. I will not do it. I'm not going to ask anyone on my team to do it. Done, right? So, then what? Okay, well, there is still this tension, right? The development team, other things being equal, does have an incentive to create ops work because building a reliable system takes more time than building, let's call it a less reliable system. There's lots of other words. And if the development team at their core wants to launch lots of features, why shouldn't they, right? So, as I say, it's so tempting. The problem is slightly deeper than that, actually. If you're in a development team, typically, you're not actually doing any of this operations work yourself. And there's a wonderful book out there. If you haven't read it, I recommend reading it, called Thinking Fast and Slow. Right? It's a great book. I see some heads nodding. Yeah, it's terrific. You won't read it in a day, by the way, but keep at it. One of the observations there is that most of the time, and this is for everybody, most of the time, what I see is all there is. It's very hard for me to remember that there are things going on that I'm not exposed to regularly. And this is totally true for development teams, right? If they don't see the operations work that occurs, the ticket flow, the server repairs, the endless streams of logs, it will very quickly no longer be in their conscious. So what I see is all there is. If I can't see the operations work, it doesn't exist. And as I just said, working on production, that slows down feature development. So I don't want to do any more of that than I have to. So this is another incentives problem, just like error budget. And we actually do 6 different things to fix it. All of them work in combination. They work really nicely. Let me just run through them. I think you'll see how they both work and fit together. So number 1 is we actually have a common staffing pool between SRE and development. Not 2 separate pools. So, you're working on Gmail, great, you get whatever, 50 new developers this year. That's 50 new developers and SREs. Well, how many people do you want to put onto SRE? I don't know, right? As few as possible, because every person I put into SRE means one less cool developer who's going to be building nifty new Gmail features that will win the world over and drive our competition to drink. But you need the SREs if there's operations work or et cetera, et cetera, et cetera. So you can't if the system doesn't work very smoothly on its own, right? So have a common staffing pool, single set of headcount, basically means the more operations work there is, the fewer features there are. And it's a totally self-regulating system, right? It aligns your incentives because the development team is behaving rationally. They want to build features. And if they realize that a system that requires very little manual intervention, very little headcount to operate, means that they get more developers each year, they will gravitate toward that one in a hurry. And in fact, in practice, what they do is they try to figure out what exactly the right ratio is so that they spend just enough time on production to not increase the demand for SREs over time as the system scales, which from my perspective works beautifully because the SREs will also like to not see that demand for them increases at scale. What that means is that none of the things that they're spending their time working on have anything to do with scale, which is good because that's the boring work anyway, typically. So, self-regulating systems for the win. Second principle, SRE only hires people who write code. Now, I went back and forth about whether to say software engineers or software developers, blah, blah, blah. The reality is different companies use different terms to describe what ends up being a very wide spectrum of skill. But from my perspective, the thing that's actually important is that everyone in SRE is able to write code that does non-trivial things. And that means both that they can design a system to do something that isn't, sort of script level, and that they have a very keen appreciation for what a computer can do and what a computer can't do, to be fair. I find that almost universally that comes with one additional very nice feature, which is, like me, they're very easily bored. Right? I want people who are easily bored. I don't want people for whom it is gratifying to sit there and process, 30 of the same ticket, right? Not what I'm looking for in SRE. I want people to look at that and they'll do 2 of them and they're like, okay, I know how to do this. This is boring by the 4th one. I'm going to write some code that'll do this, integrate it with the main system and move on to the next problem. That's what I'm looking for. So call it what you will. What we're looking for are people who write code and enjoy writing code. Next up, pretty simple but important. I put a cap on the amount of time that the SRE teams and individuals are allowed to work on all operation stuff combined, right? On-call, tickets, maintenance, blah, 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 blah. Operations, we've spent some time, we've spent some time inside of Google actually defining exactly what is and isn't operations, because there's always stuff sort of in the gray area. But roughly like certain other things in life, I know it when I see it. And what we want is to ensure that the SRE team does not spend the majority of its time on operations work. Now, in practice, actually, what I found is the team spends about 30% of its time on operations work, and that seems to work pretty well. The point of course, is that you want most of the team's time spent on writing code. Why? Well, I'm assuming to most everyone here it's obvious why, but I'll spell it out anyway. Because if you succeed, your service is going to grow. And if your service generates errors as a result of traffic, then when it grows, it's going to generate more errors and more maintenance and more ticket and so on. So basically, what you've created is a system in which if you are successful, you will die. It's not a good recipe for success, by the way, right? And conversely, right, the only way to survive is to not have your service be successful. I don't recommend that one either. So you have to leave plenty of time for the team to spend writing code, building systems, improving the service that they're working on so that it doesn't generate much operational load so that you can grow and succeed. And simple as that. So another bit, and this one turns out to be important, and it's the hardest one to negotiate, so I recommend for those of you who aren't managers here, which I think is many, but not all of you, this is a good place to engage your management chain and teach them how to negotiate. You have to keep the development team in the rotation, and in SRE and in Google we do. Typically what this means is 5% of all operational load gets handled by the development team. I have found in practice it does not take very much at all. But again, it's that what I see is all there is problem, right? If you don't see any operations work, it's easy to forget that it exists, and it's easy to imagine that it's easy, right? Or simple or short. Whereas, right, if your cubemate grabs you on Wednesday because they didn't sleep on Monday and they didn't sleep on Tuesday, and it's all because that bug that you downgraded to P2 that's sitting in your bug queue because you didn't think it was important because it was some operations thing that you never have to deal with, right? They grab you by the scruff of your neck and say, you will fix this bug today, right? And I've seen this happen. It's great. It's awesome. As I like to say, nothing builds consensus and clarity on bug priorities like a couple of sleepless nights, right? So 5% of the operations work, tickets, maintenance, and on-call in particular, should go to the development team. Now, be aware, right, they will fight you on this. There will be a litany of reasons for why this doesn't need to happen. They really care, right? SOX compliance doesn't, that was my favorite one. SOX compliance doesn't allow us to work in this code. Bullshit, right? So this is where engaging your management chain and occasionally, getting a big scary VP to show up and say, yeah, you know what, it's still gonna happen, right? I don't believe you. It's really, really important. What I have found is every single development team resists this a priori mostly because I think they assume that it goes from 5% to 50%, and then they can't do any of the development that they wanted to do, and no cool features get emerged, and all of their competitors lose their alcoholism, and anyway, blah, blah, blah. But they absolutely resist it, and once they do it for about 6 months, no one can ever imagine going back, right? It's like, oh, this is clearly the right way to do it, because we totally understand how this system works, and now we're working really closely with our SRE counterparts, and we're making sure that we build a reliable system, and we all agree on the bug priorities, and we're able to innovate so much faster because we're not spending any time dealing with production instability. So every single time they fight, and every single time afterwards, it's awesome. So do this one, and grab your manager. Make them earn their paycheck. Speaking of development and operations balance, one of the other rules we have, and this is an important one, is remember that 50% cap. So when the operations workload goes above 50%, when we start getting into what we call operations overload, all of that work is simply reassigned to the development team, right? It's pretty straightforward. You take the ticket and you reassign it to them, right? And if they don't fix it, well, then the error rates start going up, and then you blow your error budget, and then launches stop. And so, usually pretty quickly in that cycle, everyone figures out that they have to actually do the work. Usually they're actually cooperative. But all of the excess development or operations work, flows back over to the development team. And again, it's a self-regulating system, because if they're working on the operation stuff, they're not developing features, which means less change, which means less problems. Plus, they'll end up fixing the code to generate less operations work, which means more stability, more error budget, more launches. And so it's exactly this regulating system. But it's also why getting that first 5% is really important, because then that means they actually know how to do the work. So I usually do it in that order. First it's 5%, and then the overflow also goes. And lastly, but I'm way behind on my notes here. Lastly, but also very importantly, is this concept of portability. So this is one of those situations that you don't want to have happen, but that everyone needs to know can happen, right? SREs are portable between different SRE projects, between different organizations, and in many cases between SRE and other groups inside of engineering, software engineering, platforms, kernel, you name it. And I will never block an SRE transferring off a project. People at this point know not to even ask, but it's happened in the past. I will never ask someone to stay on a project that they don't want to stay on. And this is crucially important, right? In fact, they don't have to stay inside of SRE. Everyone who's working in SRE eventually is a software coder, right? What we like doing, presumably, is actually building cool systems, writing code, solving problems, making things work, etc. If you give someone a job that sucks, right, a system that's broken, an uncooperative development team, etc., they will not advance their career working in that group, right? You can possibly convince them to do it, but it will not be to their benefit to stay in there because you won't learn anything going and doing a bunch of manual work, repeating, tickets and maintenances and so on. Your career will stall at that point. I don't want that to happen to anyone in my team. So it's a simple rule, right? If you want to leave the team, leave. About once every other year at Google, an SRE team blows up, right? You've actually got it bad enough that the development team, the SRE team, can't see eye to eye. They haven't done a lot of these sort of incentive sharing things for one reason or another. And the SRE team eventually says, you know what, we don't know how to deal with this. And my answer is, okay, actually I do know how to deal with it. We're going to take all of you. We're going to move you to other healthy SRE teams so that you relearn, right? If you want to move off to development too, you can do that. That's fine. But we're going to move all of you off, and we're going to disband this team. And the development team goes, what happens? The answer is, what do you think happens? See this pager? Here you go, right? See this ticket queue? It's being reassigned to you, right? And I don't want this to happen, right? It usually results then in no innovation in that product for like a year, right? It sucks. It's bad for the company. It doesn't make anybody happy. There's lots of VP equivalent of yelling. But it's absolutely necessary that everyone understands that it can happen because it provides an ultimate incentive for everyone to actually cooperate and do all of the other steps that I've got in there. And so about once every other year, I let that happen. And that seems to be sufficient. So as I say, this is a threat that is very rarely executed, but it's very powerful. And it's powerful that it's important that it's credible. At this point, everyone knows outside of Google that if it goes all the way up to Larry, he'll support me. So nobody does that argument anymore. If you don't get that support inside of your company, try to get it. All right. So that's the how do we deal with the work that SRE does and staffing and so on and so forth. So now let's talk about the last bit, sort of the third plank, and I will try to speed it up, which amazes me. I figured I'd be done early. Despite all of this, despite great cooperation between the teams, despite error budgets, despite good work mix and people's careers and blah, 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 we do have an SLA that's less than 100% on every product we've got. That means there are going to be outages. Here's the key. An outage is actually okay. Right? It's not fun. I don't enjoy it. Right? Every single time I see a 500 message come up on Google, my heart rate goes up personally, and my hands sweat, all the normal stuff. It's not any fun. But it's actually expected, right? Having an SLA below 100% means that you'll have outages. And the trick then is that when there is an outage, you want to do two things. First is you want to minimize the impact, and the second is you want to prevent recurrence, right? I want to have another outage because my SLA is below 100%, but I want it to be something different, right, next time, because that lets us innovate. So minimizing damage, well, fundamentally, the size of impact is about duration and scope, and the total impact is duration, scope, and frequency. So we like to say that MTTF and MTTR are important. But key for the SRE team is that when there is a problem, the damage occurs between the point at which the problem starts and the point at which the problem stops, right? Multiplied by the number of people who are affected by the problem. So your goal is to minimize the time between when the problem starts and when it stops. And that breaks down into noticing it quickly. And by quickly, for a 5.9 service, we're talking seconds, right? Totally doable, by the way. And minimizing the scope, how many people are affected. So in practice, what this means for SRE is there's no knock, right? Because a knock is basically just a load balancer, right? Sometimes stateful, sometimes not. But it's a load balancer, and those add latency. No place for that in a high SLA service. So there's no knock. Alerts go straight to the SRE team. And in particular, they go straight to somebody who is capable of actually fixing the problem themselves. This is very, very important. Secondly, alerts, when they occur, have to have great diagnostic information, right? Getting the alert that says there may be something wrong, in this cluster somewhere, worthless, right? Getting an alert that says, you are seeing high latency on 13% of queries from this cluster to that other cluster, that's valuable, right? That allows you to do a pretty quick differential diagnosis and figure out what's going on. So good diagnostic information allows this competent engineer who's received the alert to more quickly fix the problem. And the third, which I think there's probably most variance in practice that I've seen in companies, is you actually have to practice a lot, right? And 2004, we started talking about practicing. Nobody really believed it, right? Because there's this sort of myth of, well, we're engineers, right? And so when something goes wrong, we'll figure it out. And the truth is, yes, you will figure it out. In the post-mortems, it typically took you about 3 times as long to figure it out as it would have if you had behaved ideally, which you couldn't because you were figuring it out. And that means the outage was 3 times as big as it needed to be. So, what do you do? Well, maybe we can do better than that. Maybe we can figure out what we would do when this happens, before it happens, and then we train everybody so that there's a high probability that they'll do the correct thing when it occurs. Okay, so it sounds great, but how do I phrase this? If you tell a group of engineers, hey, guess what we're going to do? We're going to do operational readiness drills today, right? You can almost hear the nictating membrane just slam down over the eyes, right? Like it's over, right? But I'm a software engineer too, so I'm hip to this game. So we're not going to do operational readiness drills. We're going to do Wheel of Misfortune. And Wheel of Misfortune, as it turns out, in its various different flavors, the ads team, for example, has Octagon of Poverty and so on. You're engineers, you're endlessly creative, I love it, right? This is one of the most popular SRE events, right? And basically what we do is we create a pie chart with roughly the different kinds of outages that we've seen in frequency distribution on the pie chart. I've got a simplified version here, because if I made an actual one, you wouldn't be able to see it. But this is kind of what it looks like. All right, so the things we worry about for this particular service, right? There's Sharknado, there's sharks with lasers, there's Sharkvalanche, and then, of course, the all-ever-popular bear cavalry. And literally what we do, right, is one person acts the part. Well, actually, one person is typically one of the on-call engineers, right? And one person plays, for those of you who remember Dungeons and Dragons, right? One person is the dungeon master. You tell the person what they see. They can ask you questions. You tell them what the answer would be, et cetera. You play both the outage as it unfolds with the alerting system and the monitoring, as well as answering questions and so on. But the person has to figure out what the problem was and what to do. And everyone else hangs out, doesn't offer assistance unless they ask for it, but takes notes, right? Because what you're seeing is in an actual outage, this is what would have occurred. You take notes, how can we do this better? Maybe we can change our monitoring system so they would have gotten an alert about this particular problem sooner. Maybe we can change we don't have operational drill books, obviously. We have playbooks. Maybe we can change the playbook to tell them, try this thing next. Maybe we need to actually build a new system, right? You learn a ton by doing a dry run of an outage before it actually happens. And it can be a lot of fun. In SRE teams, it's a huge amount of fun. So practice, practice, practice. Your whole goal is to get the amount of time between the problem start and the problem finish as short as possible. And we have seen over and over again that practice cuts it by 50 to 70%, which is huge. It's a lot more features you can launch. So once you fix the problem, right, then what? Well, got to write a post-mortem, right? Every single outage has to have a post-mortem. The whole point of a post-mortem is there will be another outage. I don't want it to be the same outage next time. I want it to be a new cool outage that we hadn't thought of before. So your point in a post-mortem is to understand exactly what happened, how it happened, when it happened, what the timeline looked like, who knew what when. And usually, I mean, probably most people here have done a few post-mortems. If you've done a good detailed one, you look at it, you go, oh my God, right? There was mass confusion. No one knew what was going on. 3 different people working stuff. That's normal, right? It gets better with practice and with post-mortems. But you actually have to be brutally honest about exactly what happened. And one of the key bits in the post-mortem, I think I get to this, so yeah, I'll get to that in a second, so skip that. So you do the post-mortem, and then, you know, having finished the post-mortem, you have to actually reset because something may happen again. So generally speaking, if we say this is the goal of the person who's dealing with events, right, the on-call engineer, they have to handle the event, start to finish. They have to write the post-mortem. They have to be reset and ready for the next one. This actually means that you can handle 1 or 2 events max per 8 to 12-hour shift on-call. And so we actually set that explicitly and we measure it, right? How many events did you have? Now, one event can generate multiple alerts, right? That's just the nature of distributed systems. But 1 or 2 discrete events per on-call shift max. If you're getting more than that, you are not able to do the job that actually needs to be done, which is to fix the problem and then write the post-mortem so it won't happen again. And basically what you're agreeing to, usually what happens, you fix the problem and don't write the post-mortem, right? Or you patch the problem and don't write the post-mortem. What that means is you're agreeing that this same outage is going to happen again, right? You don't want that, right? That basically means your operational load is going to go over time. So you need to call a halt when you find that you're getting more than 2 events per on-call shift reliably and either split the on-call rotation or start throwing work back over to the development team. So SRE has a principle, it's simple, 2 events per on-call shift, and also minimum group size. This is very important because if you're tired, fatigued, sleep deprived, you will not do this job well. Both the outages will be longer and your post-mortems will be less complete. So simply we have a minimum group size for any on-call rotation of 8 people if they're in one location. And that only typically works when the service has most of its problems during the day. If it has problems 24/7, this simply doesn't work. Or 6 people times 2 locations. And that actually works very nicely. We found that, you know, 1 group of people in the US, 1 group of people in Europe, or 1 group of people in Asia, 1 group of people in the US, that works pretty nicely. But these are minimum sizes for the teams. And if you have too many events, you have to create a whole new separate team of the same size to deal with them. Otherwise, as I say, you're agreeing to death by operations overload. So lastly, let me talk about postmortems themselves. This is really, really important. The key bit with postmortems is they are blameless. And they're blameless for a very simple but very important reason. I assume that everyone in the team is actually intelligent and well-intentioned. They were all trying to do their best, and they actually are skilled. They're bright. We interviewed you, right? And yet, despite all of that, you still had an outage. It's not the person, right? It's the environment. So our postmortems focus entirely on how do we fix the technology, the environment, the process to make it easier to avoid the outage or easier to fix the outage when it does occur, right? And by doing this, obviously, it focuses on something that you can fix, which is, you know, your systems, your tools, the way your service works. And it invites people to be honest about the mistakes that they made, because we all do actually make mistakes. And by seeing what mistakes they made, we know how to change the system so it's easier for them not to make that mistake next time the thing blows up in some way. And, you know, I can't emphasize that one enough, right? We did a presentation recently at Google where we called a bunch of people who had blown Google up on stage to talk about, you know, how it happened. And the key, you know, one point was to talk about what happened. The other point was they're all still there, right? So postmortems are blameless. They have to have a lot of detail. You make a timeline, you get all the facts. And then last, but important still, right, all of the things that you decide to do in the postmortem, put them in the bug system, right? If they sit in the dock for the postmortem, you know what's going to happen. 0, right? So put them into the bug system. It's a system we all use to keep track of things we need to do, and then they'll get fixed. And that is actually it. 11 years of experience having named this team and then built it from 7 people to 1,300 at SRE, and now very gratifyingly seeing it spread way beyond Google. It's all these things and nothing else that I could think of. So with that, let me leave you with the SRE benediction. Right. May the queries flow and the pagers remain silent. Thank you.